Hello, everyone. Today is Wednesday, August 18th, and this is the Cluster API office hours. As always, please follow the extensive code of conduct when you're in this meeting. And if you don't have access to this document, you can get it by joining the SIG cluster lifecycle mailing list. Please use the raise hand feature of Zoom if you'd like to speak, and feel free to edit the agenda in the doc if you want to add any discussion topics. If you haven't already, make sure you add your name to the attendee list, and let's get started. All right, I don't think we have any PSAs today. In terms of releases, we have V041, which has been released 6 days ago. And I think folks were already asking about the timeline for 042. But I don't think we have an ETA for that yet. Am I missing anything? Anyone want to add on top of that? All right, cool. So I don't think we have any blocking issues at the moment, but let me just check. Yeah, okay. And then I guess proposals, would anyone like to give any updates on any of these currently open proposals, or anyone blocked on anything? Are all of these still accurate and still being worked on? Is there anything we need to remove from this list? Okay, I'll assume that's a no. So let's keep going. All right, we have the first topic, cluster schedule generate cluster enhancement. Yuvraj?
Yeah. Hi, everyone. So this is regarding updating cluster CUTL generate, basically enhancing cluster CUTL generate cluster to work with cluster class and manage topologies. I can open the issue and share my screen. Oh, I can't share my screen. That's fine. Yeah, awesome. Yeah, so the issue here documents basically two things that we want to achieve. One is the primary goal would be to basically keep the quick start flow as simple as possible, even when someone's dealing with cluster class, right? So it should still remain as simple as a user running cluster CUTL generate cluster. And the second thing is provide a way for all the providers to opt in whenever they're ready to start supporting cluster class. And the way that we are proposing here is in the template examples that we share that are released as release artifacts in the providers, we'll use the class definition that's provided within the template. And if the class definition points to a topology, we'll check if the topology is already defined in the cluster. If it is, just use it. If not, go and fetch a cluster class definition file from the release artifacts and then add it to the template that gets generated at the end, generated as the big YAML file. So the implications of that are explained here. So there are two things that would change. One is changes on the provider release artifacts. So the providers can either add or modify their existing cluster templates to look as an example. So an example is attached on how a potential template should look, an example should look like. Some changes to highlight are like the class definition template that we have right now has like class and meshing deployments and templates and all of them. With the new approach, it would just have the cluster class definition and just point to another topology. And there will be a separate class with the topology definition, the templates, and separate file with the topology definition, templates, and everything. And again, this is going to be completely optional for providers to move in. So as long if the providers continue to just ship the existing class definitions that they have been shipping, it'll still work because the class will not have any pointer to a topology. Therefore, ClusterCuttle will just fall back to whatever it's been doing till now, and it'll just continue to move forward like that. More details and examples are listed in the issue if anyone wants to go to them. But yeah, like open this issue to start a conversation about like feedback on if this is okay, if there are like any other points that need to be addressed or thought about.
Awesome. Thanks for opening such a detailed issue. Does anyone have any questions? I have a question. You say I would like to keep the quick start flow as simple as possible when using cluster class. Is the implication that at some point we'll want to move the quick start to using cluster class? As in, do you see cluster class as being a good scenario for a first-time user, or is it more something that you'd want to keep out of the quick start and would only be more like for advanced use cases?
So cluster class itself is like has a better impact when used the second time, like basically have the class definition. When you're creating your first cluster, the flow for creating it using cluster class or the old approach is basically roughly the same, but the impact is shown when you start creating your next cluster, like the second cluster. So I would say that it's completely up to the providers to choose if they want to do cluster class as their very first cluster, or if they just choose to do a simple cluster as their first cluster. Fabrizio. Sorry.
Yeah. First of all, thank you for opening the issue. I think that, yeah, I totally agree. The advantage for the user is when they start creating more cluster of the same shape. And but I think that as soon as cluster class is mature enough, I will recommend to the provider to start migrating to cluster class, so we start shifting the user towards the new model.
Okay, makes sense. Yeah, I guess the only reason I'm saying that is I feel like ClusterCuttle already is, it was meant to do mostly management cluster operations from the start, right? And the generate command is more like a convenience for the quick start. But I don't know if we want to like keep expanding the scope of ClusterCuttle, like in terms of like workload cluster creations, if it's not going to be a quick start scenario, because most users can't use ClusterCuttle generate already anyways, because their configurations aren't going to be in the provider repo for more advanced use cases. So that's the only thing I would think about. Like, does it really make sense to take this on, or do we want to stay away from that?
I think that we should do this because being ClusterCuttle used as a library, ClusterCuttle generate can be used, let me say, as a separated pieces. And given the report that we got in the issue that we got in the past, I'm pretty sure that people are using these to create cluster after init.
Yeah, that's a great point. Maybe something that we should add as a user story. Like, as a user, I want to use ClusterCuttle as a library to deploy cluster class clusters. Vince?
Yeah, you'd plus one on that. I think like for the quick start, it's probably something that we'll need to wait for the next version of when either there's no feature gate or the feature gate is enabled by default. Right now would be, kind of, yeah, you have to set the feature gate before using it. And yeah, for ClusterCuttle, like I think would be great to support it, mostly because like it's also, now that we're like distributing in Homebrew, and like potentially we could do this like with other Linux and other package management systems. It would be great to have like a more streamlined user experience for ClusterCuttle long term, especially if we move some of the operations in the operator. It could just become like a way to simplify the quick start.
Yeah, cool. Any other comments or questions? All right, feel free to add comments to the issue afterwards if you have thoughts. All right, Jacob, you want to talk about the IPAM integration proposal?
I haven't worked on it for a few weeks because I was on vacation, but now I'm back to it. And I'm currently having, well, a problem with the consumption part of the proposal. So just as a brief summary, the idea is to have IPAM or integration with IP address management that works similarly to how persistent storage works. So you basically have pools of IP addresses, and then you can create a claim system similar to a persistent volume claim that references the pool, and then something or some controller, probably provider specific controller, fulfills the claim with an IP address. And the problem now is, how do providers or machines or provider machines consume those IP addresses? And the struggle that I have is that right now CAPI instantiates machines from the templates. And so from that perspective, the most obvious thing would be that it also creates anything or any dependencies that the machines have, like in this case, that would be such IP address claims, because you would need one claim for every interface that needs an IP address for each machine. So the question is, does CAPI create those claims, or does the provider have to create those claims on its own? And there are some pros and cons to both approaches. And I just wanted to ask for some feedback on those two options. I did so in the Slack yesterday, but I just wanted to mention it here. Ideally, I guess, because that's a lot of stuff to present and to review, it should probably be offline or async. So I'm just advertising for it, basically.
Yeah, thanks for advertising. So yeah, unless does anyone have any thoughts they want to share right now, or? Okay, if not, yeah, please go ahead and take a look. Oh, Arun, go ahead.
So I have a question, and this may be based on some of my ignorance. There is a movement of a cluster and so on, right? So that is within one provider. Can we be sure that the claimed IP address remains stable when the clusters are moved? And
I didn't really get
so
what you mean.
Okay, for example, so there is this, I'm actually talking about something generic which has been going on in the architecture channel. Each Kubernetes cluster has something which is within the cluster and a set of provider properties. Now, there is the general thought of how reproducible can a cluster be, whether you can snapshot and recreate a cluster at a different location or at a different point of time. So if you actually claim, will there be some way of actually reusing the IP address if you actually just restart the machine, for example, or restart the cluster? Okay, I'll actually.
Still not 100% sure what you mean, but if you have, like, if a machine creates a claim and then that claim gets fulfilled with an IP address, then it will stay that way as long as the API objects exist, at least from like how the proposal models it right now. If you want some more persistent behavior, that may be then something provider specific that you could do, so that it may, for example, hands out IP addresses based on the name of the machine that requests it, or things like that. But as long as the objects stay the same, I would have it in a way that the machines keep the same IP addresses.
Okay, sounds good. Yeah, I mean, I'll ping you offline in Slack to understand this. Thanks, Jacob.
All right. One quick comment I have is you said the CAPI creates the machines. That's not always true. Like, as a user, you can also create individual machines. You don't have to go through a machine deployment with a machine template. So just something to keep in mind. I think it should still work if a user creates an individual machine.
Yeah, but in that case, then they would just have to create the claim on their own as well.
Yep.
But yeah.
All right. Everyone else, please take a look and add any comments you have on thoughts between the two approaches.
Thanks.
All right. I can't see because it's hiding, but I'm pretty sure. Oh, Mateusz, yeah, ignition support. Go ahead.
Hi everyone. So yeah, we decided to move this discussion to the weekly call because we've had this PR with the ignition support open for a while, and we collected like a bunch of reviewers. Many people actually wait for this functionality, and yeah, we also got like several engineers from like formerly Kinvolk, now Microsoft, to work on that as well. And yeah, Vince recently suggested that perhaps with the move to V1 beta 1, that maybe we should make this PR a separate provider. And yeah, and I disagree because I think that there is like there would be too much of the boilerplate and copy pasting of the code, or like making that like importable and as a dependency to make it a separate provider. And yeah, I would like some guidance, like how can we move this forward? Yeah, so at the moment, like on the Kinvolk side, we've been like a little bit unorganized, and like we didn't push it forward. We didn't get time to make the end-to-end tests, which were suggested. I think you, Cecile, suggested adding that. But yeah, we again have resources to work on that. And yeah, so yeah, I wanted to know your thoughts and maybe to gather some ideas.
Vince, did you want to expand a little bit on your suggestion?
Yeah, so I was looking again in the PR the other day, and there is extensive changes. There is also like to the current code base and the types that we're supporting. So like for folks that just to clarify, like what this is trying to do is like we have the CAPK types today, and those have like those include like things that are like specific to Cloud Init. And what this PR is trying to do is to make most of those fields compatible with Ignition as well, if you choose to use Ignition. Is that a fair like recap of what we're trying to do?
Yeah, exactly. So instead of producing like Cloud Init, we'd like to produce the Ignition. Yeah,
so there were some concerns that like popped up like here and there, like for like for example, that is like a free-form string for like additional config, which I think we need definitely to validate. There was a question of ownership, like who's going to own the code and how we're going to test it over time, and who, if this breaks, like who can we call to fix it. And there's definitely like the question of end-to-end tests, which, like given that we've released 0.4 at this point, I do think this should probably come with the PR at this point. Or we need to block the release. The other thing that we could do is to put all of this behind a feature gate as well, and make it disable by default for now, so that we're sure that like all the code is gated. And yeah, I guess like that's mostly it. The most important thing is to make sure that we have a pool of people that we can rely on if something breaks. Personally, I don't have any experience with Ignition, and it was really hard to me to like debug it as well.
Yeah, so I think from the ownership perspective, we already have 2 engineers, so me and Dongsu, which is also on the call, who are the owners and reviewers. And yeah, we also got Johannes, which recently started working on that. So yeah, I'm sure he'll also be capable of like doing the reviews or managing that. And yeah, we still have like the Flatcar team, which yeah, we might be able to pick someone extra from this point of view. About the feature gate, can this also be applied for the API fields? I don't think so.
Yeah, what you can do is what we have done for cluster class, which is being developed. You could use the feature gate in the webhook code to gate those fields, and so you say like, hey, you cannot use this unless you actually enable that feature gate.
Oh, okay, thanks. Yeah, I mean, I don't mind if you feel like more comfortable with doing that initially, then yeah, I think we can do that. About the tests, yeah, I agree, and I agreed on the issue that we need to add some. And I know that you right now have like this not greatest way of testing the cloud init config, because you just parse it, I think, like by hand, and then you execute that in Docker. So yeah, we could do the similar thing with Ignition, I suppose, because yeah, we don't have like the Flatcar based Docker image. We rely on the systemd there, so I'm not sure how this is done, like from the in the cloud init, but yeah, we may have to come up with something there to yeah, I don't know, to run systemd in the container or something. Yeah, but this is all assuming that we could get the API changes in, right?
Fabrizio?
Yeah, I would like to raise a slightly different point, which is somehow related to this PR. So as of today, in the kube-admin config object, we have basically two concerns being addressed, now becoming three. The first one is the node bootstrap, which is kube-admin cluster configuration in the configuration join configuration. And then in the same flat space, we have a lot of cloud init stuff, NTP files, stuff like that. Now we are adding a third concern, which are Ignition, that partially overlap with cloud init, because in part Ignition use cloud init as well. So my major concern, apart from the, let me say, maintain the code, stuff like that, is that from a user point of view, the kube-admin config is kind of a bulk of slightly related concern, and it is kind of hard to use. So so my point, I don't have a solution in mind. I was hoping that the work for machine bootstrap was something going to address this, but at least in my mind is something that we have to improve in future in terms of usability, in terms of cleanness of the API design.
Yeah, I've also suggested that perhaps the cloud init conversion could be happening somewhere else, and to have some generic type for, so that the bootstrap provider only generates what it needs, and then like the extra information can be added somehow else, or the conversion to the cloud init or to Ignition could be happening somehow externally.
Yeah,
this
but
might also be related.
Sorry, I'm not really concerned about the code. What I'm concerned more is about the API surface, or the goal of the bootstrap provider, because it is becoming too much things, and this, I fear that this will be confusing for the user and also for the future of this component. So it's kind of call to ask ourselves if we can do better in this extensibility point for cluster API.
Yeah, I'd like to add to that. I plus one to what Fabrizio said. I think for me, looking at this, like one of the promises of cluster API when like we discuss the architecture is that it's completely modular, and you can like plug in your own infrastructure provider or your own bootstrap provider, right? That's one of the big like pros of using it. And what we've done by bringing in kubeadm bootstrap provider into the main Capi code base, originally the idea was we're just going to make it the reference provider. but that doesn't mean others shouldn't implement their own provider, just like Docker infrastructure as a reference provider, but like we have a bunch of infrastructure providers. And what I fear we're doing here is we're just like overloading the KubeADM Bootstrap provider and like adding in all the new functionality there because it's easier than going and creating a whole new different Bootstrap provider. But then from a user perspective, then it becomes non-modular and like it's not what it was supposed to be, because then you're like making tight couplings between the Bootstrap provider and cluster API. And I think if I remember correctly, like the whole point at the beginning when this PR was opened was that there was this like proposal, right, for the kubelet, secure kubelet bootstrapping, which was going to introduce a whole new Bootstrap provider, which was going to solve a lot of these problems. And so we're saying we're just going to add this into KAP-PK for now to like allow ignition support as a quick remedy, but then later on it's going to be replaced by this new thing. But we're at this point now where it's been a while, the PR is still open, and like we've already released V1 Alpha 4, so it's clearly not a quick fix anymore. So I think we should take a pause and think about, you know, what we're trying to do here. And I see a few hands made here.
Yeah, it's actually worse than what you think in some way, in terms of our current architecture. We actually have close coupling between the infrastructure providers and Cloud Init as well. So yes, the kubelet secure authentication resolves a bunch of problems, but it doesn't resolve control plane initialization and protection of key material during control plane initialization. Right now, AWS has specific code to store data in another service, encrypt it, and then it hacks Cloud Init and decrypts the data and then restarts Cloud Init. And there is a PR for ignition support in Kappa as well, which adds the ignition specific mechanism to transport control plane key material securely. This sort of comes back to the project proposal that we never had reached proper consensus on, which was to redesign the bootstrapping mechanism, or at least what's the boundary between what's in the core repo and everywhere else. And I certainly think moving to a position where we definitely need some sort of agent that's on a machine that is able to pull key material from whatever secret store that you have, and then we can more easily just string template an ignition template or Cloud Init and not have to care about the particular bootstrap mechanism. I think we need to revisit that, and then that moves us out of having to care about Cloud Init and ignition or whatever.
Mateusz? Did you still want to say something? You're muted.
Yeah, sorry. Yeah, I don't have any comments for Nadir, like what Nadir said. So if someone else wants to begin, then please go ahead. I have some other like next step in this discussion, I think.
Yeah, I guess Nadir, about what you said, it makes sense to me. The question is just what do we do in the meantime, because this isn't going to happen overnight, and right now people need ignition support, so we're not going to, you know, block that. Like I think it's unfair to block ignition because we've had a bad design from the beginning that's causing us to like rethink how we're doing things. But also we don't want to just like use that as an excuse to make things worse and increase the tech debt. So yeah.
Yeah, so let's say we actually create a separate bootstrap provider. We want like, or at least I wouldn't make it like ignition specific because the actual technology behind this kubeADM. So I think that would be like, again, also like kubeADM provider, but with ignition support because yeah, I don't know, this PR is adding like 10%, I think, to the total bootstrap provider code, and would definitely want to inherit all the features which are already implemented. like the Bootstrap tokens management and like whatever it's there, like validation in the webhooks and types and so on. Especially types, because the like if user wants to move from this to the one with the ignition support, it will be easier if the types will be similar. So this will pretty much create this very confusing situation that, yeah, we have two providers for kubeadm with different feature set and like living their own lives. And also like the maintenance efforts will be also going like will be doubled, right? Well, on the other hand, this will allow us, like having a separate provider will allow us to actually change the types. So maybe we can make it more modular and less like cloud init specific. But yeah, do you think this would be like a better approach for this, or at least in the short term?
I personally don't think forking the whole thing and having duplicates is better. And also, as Jason points out, Jason, can you expand on that? The control plane provider would require forking?
Yeah, so right now, if somebody wants to leverage the kubeadm control plane provider, which I would assume, they would want to do if they're using, kubeadm as the basis for their bootstrapper, because that's tied so tightly to the actual kubeadm bootstrapping types that we have right now. If you created a separate kind of bootstrap provider, you would also have to create your own kind of control plane provider and replicate all of the logic there to be able to consume that other bootstrap provider, because you can't really, there's so much intermingling between the control plane provider and the bootstrap provider that you can't just basically treat them completely independently, if that makes sense.
Vince?
Yeah, the huge plus one to that, like, I mean, we found this exact problem, like when Fabrizio mentioned, like we were trying to work on the kubelet secure authentication as a different provider, and then it's like, wait a second, like, like we'll need to redo the whole thing. And then things kind of stopped at that point, because, forking KCP is like another thing, like we need to make it better. And like in general, like I think like what we're trying to say, like, and it's like kind of referred to this like a meta kubeadm bootstrap provider, and it's truthfully like we want you, most of like the users that I've seen, like do use kubeadm somehow. So if we try to find a way of like separating the current bootstrap provider from being like cloud specific, we'd have a kubeadm library that we can use in Cluster API, and then we can give that input to a black box that just says, like, I want to generate some, I guess, like some data to then give to the machine. And then that's the machine bootstrap. That's just like, that's the actual provider that should be in place. And then if someone wants to replace the whole chain, so like Kubernetes bootstrap and machine bootstrap, but they should be able to do so as well. And thinking about the Taos provider, for example, which replaces the whole chain. I do think though that like, making kubeadm a little bit more exposed from one side in Cluster API, but replaceable, and the machine bootstrap separated, like truly separated from kubeadm, would be both, we'll have two wins, like, because from one side we could actually expose kubeadm types, generic types that now we have in the code base a little bit more. And if someone wants to use that, that's great. Or someone can use like a completely different provider for Kubernetes bootstrapping, which is also okay. And then we could use this to provide a better user experience as well. And then the format, it's actually like, what comes into play, which could be a different provider altogether. But if all of these are based on kubeadm, we probably need to provide a way to define input and output of these systems first. it's a huge problem to solve. I don't necessarily think we need to block this. I do agree with Cecile. That's like, we have discussed this from 6 months ago at this point. So probably it's fair to merge this with, you know, a feature gate and end-to-end tests potentially, and some docs on how to use it. At the same time, like, you know, we should probably commit to make the current CAPDK code as a library. And then as we approach beta, we take that into account when, if we want to, you know, do some changes in our types to reflect that.
Yeah, so like right now, the Bootstrap provider creates a secret, which is then consumed by the machine. So if we introduce like a separate type, like we would need another object, right, with the outputs of kubeadm, and then, well, the Bootstrap provider, and then this would be consumed by the machine Bootstrap provider, right? Good to recap.
Well, I don't necessarily want to solve this here because it's probably going to be a cap.
Sure.
Yeah. It's going to be a long discussion. But yeah, from a high level, architectural level, like we need like input and output, and that's going to be defined by kubeadm, and something in the middle will take those inputs and output and generate something else and validate it as well, right? It's like, because there's going to be some fields that you cannot use across different like cloud init and ignition, for example.
Yeah, so sorry, to recap, so if we, so the steps forward for that is to add end-to-end tests, a gate for the API fields, and some documentation how to use that. And then this could possibly be merged then, right?
Yeah, sorry, I'm trying to recap this in the notes. So add end-to-end tests, and what else did we say? Sorry.
The feature gate
And
for
feature
the
gate.
API. Yeah,
And then I think we should also add like some sort of owner style for the, I don't know if you already did that for the ignition.
Yeah, we already
class.
have two owners, yes.
Okay. Before, okay. And I'll continue with this. Vince, do you want to start the next topic?
Actually, let's go to the other two first, maybe, because this might take a while.
Okay. What are the other two? June.
Hey, I just want folks here know that we have been working on another bare metal provider, which is built on top of canonical mass. We just released the V1 Alpha 3 support, and V1 Alpha 4 is on the way. So if anyone interested in another bare metal provider, feel free to go ahead and try it out and let us know. Yeah, thanks.
Any questions or comments? Mike?
Yeah, I was just curious what, if there was any note about the differentiation between this and the other bare metal provider.
Well, I think the MetaCube, the provider is mainly using like Ironic, but this is from canonical mass. Is a kind of a different way of doing the provisioning of the bare metal infrastructure. In our experience, the mass provider kind of provide a more like cloud experience for the user's perspective, and it is just a different way of doing things. I think different folks and different users might have different requirement. This is just another bare metal provider.
Okay, cool. Thank you.
All right, let's keep going. So we have two topics left. I have a feeling they're both going to be lengthy. So let's just time box each one to like about 8-9 minutes. Try to hopefully get through both. David, you want to start?
Yeah, just quick conversation that I had with someone in the community, and it kind of threw me for a loop. So the individual that I was talking with, we were talking about Cluster API, and they said that they didn't feel like Cluster API was living up to the aspirations that, you know, what they expected it to be. And I was shocked by this. I was kind of surprised. I was like, why? In saying that, they explained it in saying that, well, when I have to go build a cluster, I have to know about every infrastructure provider. Like, I have to understand all the infrastructure provider templates underneath it. The generic infrastructure, or the generic API layer, is only, you know, useful after cluster creation. And even then, I might still have to know some serious details about the underpinnings of each infrastructure provider. It really doesn't do the work that I expected it to do to abstract those infrastructure providers from each other. And so digging into that a little bit, I was curious if others have had that kind of feedback, if anybody has talked about this with other people, if you've thought about it. And one thing that I was thinking about is there some way that we could provide enough metadata that folks wouldn't have to describe the underlying infrastructure provider stuff, the details, and be able to say, hey, I want a node pool with, you know, between 4 and 8 CPUs and, you know, 16 to 32 gigs per node with a GPU or something like that. And then the infrastructure provider figures out how, like, what's the right SKU to build? Like, what is the optimal infrastructure configuration, giving these generic requirements? Having something at that level, like, maybe you don't have to give your infrastructure reference for everything. The infrastructure provider is intelligent enough to build this kind of stuff. I don't know. I just wanted to throw it out there. I was kind of taken aback by it. I hadn't thought about it, but this was really thought-provoking, and I wonder if others are thinking about this.
Thanks. See a few hands going up. Yassine, you're first.
Yeah, so I guess this is interesting for common resources that are existing across providers such as like CPU, memory, disk size, and whatnot. But I think it starts to get a little bit thornier once we get to provider-specific features, and I think those would be like the things that we wouldn't be able to abstract anyway.
Nadir?
Yeah, just thinking concretely, I think AWS is probably particularly guilty around this because, say, instance types are just sort of random strings that AWS choose, which don't really give you much knowledge around like how much CPU or memory is. I think that's different to the other cloud providers. I think this ties in quite neatly with Elmiko's scale from zero proposal, where if we're starting to fill in the infra templates with information about what an instance represents, what a type represents in terms of its CPU memory, then we can also do the inverse. So we could have like a common set of fields across infra providers that represent CPU and memory, and then have the infra providers work out the best solution to that. I think that ties in quite neatly with cluster class as well in the future. So I think we should look at that. I don't think we can abstract away everything. There's like, I think particularly for AWS, the security issues around IAM continue to be a pain for people who are not familiar with AWS as a beginners, but I've not found any real solution to that.
Fabrizio?
Yeah, I found 2 layers in the comment, and thanks for reporting the comment. I think that one is in terms of user interface of the overall copy, and the other is in terms of infrastructure provider to, let me say, make some add some improvements. So for the first layer, I think that cluster class is kind of a cluster class with patches is kind of a answer, because what we are trying to do in cluster class with patching is that basically that we hide all the complexity down in the cluster class and in the patches, and then in the cluster, what we are surfacing in the cluster / topology, what we are surfacing are just a couple of variables. And then all the magic of how variable get into the transformed into apply to the templates happen kind of behind of the scene. So I think that as a copy project, we have something that goes in that direction. It will be interesting to have a feedback from those folks as soon as we get the patch proposal out. In terms of providers, I think that this is an interesting point, because basically this person is asking, is there a way to not to provide better default, to not make the user do all explicit choice, stuff like that. This is really something provider specific, but it is a good feedback. So provide same default, trying to is interesting for me as a point.
All right, last person, and then we'll cut over to the next topic.
Yeah, I would just ask, I've been very new to the project and I've been going through a lot of the documentation, but I would be actually very interested in this and helping out. So if anybody's having conversations I'd like to be in, I would actually almost state that maybe it's not Cappy's job and maybe that's something else on top of Cappy that should be doing that. But anyways, yeah. Just trying to keep it short.
Thanks, and I think that meets also Jason's comment in the chat. So all good comments, great. I think we're going to move on to beta, if that's okay, just in the interest of time. But this is an interesting conversation, and we should definitely circle back. All right, Vince, take it away.
All right, so we discussed this a little briefly last week about there's some comments on like how do we get to beta and like how do we get to beta actually faster, right? It's like I think we could probably all agree that like in terms of like code base and stability, stability of our operations, we clearly have some APIs to fix, like as we discussed before. We are definitely production ready, like and multiple companies that are definitely using closed API in a production environment. And so how do we communicate that to the world? Like folks like usually are kind of thrown out, like when like they're like, wait a second, this is like an alpha 4. Like what's stopping us to actually like introduce API types and actually a 1.0? So the thinking from last week that kind of started making my mind spin a little bit was, why don't we take the current types and like just promote them to beta like in the next iteration, and maybe do it sooner rather than later and keep iterating on it. And there were like a few things that like came up in mind that like could be beneficial, but there's also like a lot of other things that like might not be. So one example is like, how do we introduce new features? Like it's imperative that like we keep the development up and we keep the innovation of like new things. And so like, how do we, for example, like decouple like the machine bootstrap, like if we were to beta right now, right? Like we have to grab like a new type version and then support it for 6 months or 3 releases, if I remember correctly. That was the rule. Do we follow the Kubernetes rules? So like, should we make like our own rules which are a little bit more lax, given that we have a people problem right now in terms of reviewing proposals, PRs, and also like approving them and maintaining the code base. So there is like a subset of like 3-dimensional problem here that like we'll definitely need to fix over time. Although if there is a desire from this whole community to actually get the types to beta and release a 1.0 version with the current feature set that we have. I'm definitely like, we should probably make a plan of action of what's considered like definitely something we need to fix before getting there, and time box it as well. One idea that we had, for example, was to not accept any new proposals that like have not already either merged or proposed like in the past few months, for example, and wait for those for the next iteration, if they're breaking changes. I mean, if there are like additional changes, like we would probably require feature gates, and those feature gates like will need to be promoted over time. One question that came up was, how do we communicate that a field that gets added to an existing type is actually experimental? We could do some of what we have done for cluster class, which is to gate it. And if you set it, like an error comes up about what if it's like a feature in like an already existing struct? Like, do we still do that, or also like how do we break behavioral changes and contract changes? Like those are all things we should probably think about. The huge benefit that I see from moving to beta, like apart from, from a public point of view that like the project like is more production ready, is the fact that we can actually move a little bit faster in terms of releases and breaking changes, so that there shouldn't be a release anymore in the future that has like a huge amount of breaking changes that then forces the infrastructure providers, for example, to take a really, really long time to upgrade to the new API version and minor version of Cluster API. So as an example, like we Alpha 3 for Cluster API, it's on controller runtime 0.5. This is a very simple example that like then Alpha 4, it's on 0.9. There were like lots of releases in between that we couldn't update because of the our promise, compatibility promise. If we do release more often and minor version could be released more often, we could do more of these breaking changes over time. Kind of summed up, we have 5 minutes, I guess, to go around and discuss.
Fabrizio, go ahead.
Yeah, I think that what we have to recognize is that the project is big, and in the future, but also now, there are different parts of the code base that have different level of maturity. So the problem is, how do we communicate this, and how do we remove the link that we have from the past? For instance, from the past, we have a link between the version, the release version, and the API version. 0.3 goes with V1 Alpha 3, 0.4 goes with V1 Alpha 4. This is a link, something that we got from the past and probably makes sense to break, given that in the code base there will be not anymore only V1 Alpha 4 or V1 Beta 1, but that there will be different level of maturity. And so this is one. And also, the other problem that the only big problem that I see is that while a CAPI version can support many API version, as of today, a CAPI version supports only one contract. And this is a limitation that is basically forcing us to keeping many versions of CAPI basically live at the same time.
Mike, go ahead.
Yeah, so I was, I guess, thinking more about the informational side of this. In terms of getting the message out and whatnot, have we considered in the past, or would we think about adding some sort of like a blog section or something to the Cluster API book? Just, I think we get a lot of good traffic there. That would be a place to kind of really promote changes that are happening and whatnot. Just a thought.
Yeah, what I was going to say, I think +1 to, if not using our own criteria for like deprecation policies, I think we should at least make it explicit. And I don't think we should necessarily tie ourselves to the Kubernetes ones, but even if we do, we should like define our own in the book, even if they're the same. And then the other thing I was going to say is I agree with Fabrizio that we need a better flexibility around having different maturities for different components, because we're going to keep adding new things and we can't just expect everything to come in at beta. So maybe breaking away from tying the API version and the releases together will like not only allow us to do quicker releases and have minor releases with like big features and then patches with only bug fixes, but also having that not like that concept of not everything is at the same API version. And I think the 1.0 would be a big signal to the community that, you know, we're production ready and we want people to use this. This isn't just an experiment anymore. And in terms of like the like having to maintain things for a long time, like for example, if we were to use like to add a new bootstrap provider for to replace CapBK, I'm not too worried about that. I think that even if we weren't under that rule, we would still take a long time to completely like stop like having people migrate from one to the other. And we've seen that already with cluster class, for example. Like we're adding cluster class now, but it's not going to be anytime soon that you can't provision clusters without cluster class, if ever. So I don't think we should be too concerned about that. I just think that it will just enforce something that we're already doing in some level. And I think we're almost at time, but does anyone else want to add anything?
I think just for next steps, like a backlog grooming review, it's probably overdue at this point. So maybe like before the end of the month, we should do one, and we could probably add a new milestone, which is could be 1.0, and try to identify all the release blocking issues that we want before 1.0. And in terms of APIs, like I do agree that like we need to break from 0.3 is alpha 3 and 0.4 is alpha 4. So if, for example, we could also decide that 1.0 it's beta 1 just for the core types, and for example CapBK and maybe KCP we don't promote them yet, because we could also wait for 1.1 to promote those types. Right? It's like, and we don't have to do all the ones. And with conversion workbooks, these things are pretty easy.
Yeah, and we should also update our roadmap, which we haven't done in a while. And I think it's still showing alpha 4 in there.
Yep.
And as Nadir points out, we've already had this situation where cluster CL is still on B1 alpha 3, whereas the rest of the code base is on B1 alpha 4.
Yeah, classical is on alpha 3 because we had the operator, but yeah, it's
all right, I think we're at time, unfortunately, but maybe we can continue this discussion offline if anyone has more thoughts, and we can certainly circle back next week and discuss this some more. But thanks everyone, and thanks for all the comments and good thoughts here, and yeah, have a great rest of the day.